testing, seeing if my mic's working. Yep, my mic's working. Perfect. Okay, so I wanted to go over something really cool that I've been working on all morning, and I'm very, very happy with it. But essentially, what it is, it's a completely automatic FK-IK switch that has automatic IK-FK snapping in real time based on just inputting your FK control, IK control, and the switch setting. Other settings include setting the pole vector offset and the clavicle if it's applicable. If not applicable, it will just completely avoid that. And also inversing for flipped axes IK systems. And it works with the right side and left side. But essentially what you have to do, the only requirement is when you do your FK controls, you got to do from the top bone, which is the upper arm, to the bottom bone, which is elbow and wrist. So it has to be in that order. And for your IK, you need to put, the first order is the handle, which is the IK effector, which is this right here. Got to have your handle first, and second, it's got to be the pole vector. So as long as you put your item arrays in this order, it will calculate everything completely procedurally based on the switch setting that you have here. So if I go to my switch setting here, it will automatically hide my IKs. I can move my hand up. I can rotate my wrist all around. Go back to my setting controller, enable it, and it works. I go back to my wrist and I move my wrist this way. I'm going through some skinning redoing right now, so this isn't the best skinning. And disable it again. Automatic IK-FK switching. So the way it works is once it gets the most interesting part is how it dissects the FK controls and the IK controls. So we'll go ahead and open our solve. And so right here, what the first thing it does is it has two more functions. One is a IK solve with FK snap. The other is an FK solve with IK snap. So this one controls the IK function, and this one controls the FK function. This one, and because you're putting your FK and IK orders in a specific way, what it does is it uses an index to get the order that the bones are being received in and assign what they should be. So it's getting the bone A, bone B, and bone C. So this is for the FK right here. So it's getting the upper arm here, removing the control abbreviation from the control, and then setting that into bone A for the FK solve. And it's doing the same for bone B and bone C. Down here for the IK handle, it's taking the control inputted into your IK control array and automatically setting it into the IK control and IK handle, or the IK handle and the pole vector controls based on the index. So as long as your IK handle is first, index 0 will hit it, and as long as your pole vector is second in the array, the index will hit it. And then it just needs information on what null to offset the pole vector from. That is getting the second bone, which is your middle joint, which will be your elbow, your calf joint, or whatever else. It's doing two commands. One is it's getting the null right here by just removing the underscore control and adding underscore pole vector underscore null. And this is all done with careful naming, making sure all my pole vectors are just a suffix on all my parent bones. So this ensures that I can just easily get the control, get rid of the control underscore abbreviation, add the underscore null abbreviation, and it will calculate correctly based on the array given. The way it works now for the IK solve is you enter here, and it calculates if there is a clavicle. If there's no clavicle, it just completely faults out, no processing. So if there is a clavicle, it will assign control to that clavicle. Then it will hide any controls that are not in use. So all your IK controls will be active and all your FK controls will be hidden. Then it determines limb side based on the name. What this does is this sees the input of the bone name, and if it has an underscore R on it, then it will inverse the X and Y axes. And there's a manual inverse too, in case for these lower joints. The Y is flipped on these compared to the arm, so just putting a little toggle helps just troubleshoot that issue. But for the most part, it should automatically work for most limbs. This is now your basic just IK node, it's just taking item A, item B, item C, which is effector item, and these are equivalent to bone A, bone B, and bone C that we previously talked about based on where it dissects the FK array and then assigns the inputs of the array to their respective positioning. So the wrist will be bone C, which then goes into effector item. Then your IK control input, or your input handle, which would be your IK handle, will be set here to this set transform to control, and this is set transform control for your pull vector. So this is just getting information based on here. Your pull vector control and IK handle control are being set here. Vector, get transform control, yep. Now it's the last step is just aligning FK to IK. This is easy. This is just receiving all the FK items based on the FK array given. Getting rid of the underscore control suffix to therefore assign it to find the proper bone. And then the name is going straight into just the set transform control. So this is just finding the control, finding the bone. And you can just run this procedurally because it's locating the bone, removing the suffix, and therefore removing the suffix is therefore finding our bone. A lot of this has to do with making sure your naming is correct. All your your controls have underscore control, which would be your bone name. So if your bone was spine 03, your control is spine 03 underscore control. Makes it easy to do these procedural replace items. Now let's go to the FK solve, which this is, again, hiding control is not in use. This is hiding the FK controls, or this is hiding the IK controls, and this is showing the FK controls. Then it's giving control to the FK. This is just a standard function that I was using procedurally for anything that isn't IK or anything. It's the same thing as the align IK. It takes for each input in the array, it's getting the transform of the bone, and then it's getting the transform to control and setting the transform of the bone. This is your typical just get transform, set transform for control to bone. And again, just removing that prefix control, therefore our naming is correct for finding the corresponding bone. Then once it moves there, this is just align IK handle with wrist bone. Because our IKs are no longer visible and being controlled by us, and it's being processed after the separately from the IK in this switch here. So when this switch happens, based on the switch, it's either one at a time, it's either solving and functioning the IK, or it's not giving power to the IK and giving power to the FK. So it's one or the other. They're not running simultaneously. That's why you don't have any issues where, well, why is my IK being controlled and how is it being controlled by the FK? It's not. It is they're being controlled. They can't both be controlled at the same time. One is being controlled and the other follows, or the other is being controlled and the other one follows. So let's go back to the forward solve, and we have our this is just taking get the transform of the wrist and then setting the transform of our IK control. So this is just like a backward solve where it's just backward solving the FK forward solve, if that makes sense. This is the fun part. This is where it's our separate function that I use in my setup event to set up the proper nulls. What this is doing is this is getting the offset for the nulls, getting the pull vector information, and setting the pull vector based on the position of the FK. So let's open this up. What this is doing is this is receiving host bone to offset from, offset calculation. This is the transform for the null, and then we're setting the pull vector control to that null. So what's going on is this section is taking the current position of the FK controllers, getting the translation of the bone, and then taking a rotate vector, adding, there's a value of 10, or this is where your offset, pull vector offset's coming from. That is being offset and adding that to the translation of your pull vector. So this is then put into the get transform null. So essentially it's getting the transform from the bone, which is set from your FK, offsetting a null from it, and then setting the transform at that null. Then the pull vector is being set to that null's location. That way we can, the null is doesn't actually get animated, but the control does. So this takes it so no matter what position my arms are in, if I move them up like this, take my clavicle, move it up, and I turn my IK on, the pull vector gets calculated in the right position every single time. So we'll go ahead and turn that up. We're gonna do it this way. We're gonna bring our wrist down, bring our arm down. We're gonna bring our arm all the way out. Set the switch on, pull vector placed in the proper position based on this calculation. So yeah, lots of interesting stuff. And all this code was then abbreviated to just these two. Left side, right side, 3 inputs. Specified there's a clavicle control, no clavicle control, no problem, it'll still work. Set how far you want your pull vector to be and inverse it for debugging if you need. As you can see, this messes this all up because it's not inverse. This one was built for this, but I can go ahead and set them up for the rest of my arms too. And honestly, this makes it so if I did this and got this right the first time, I wouldn't have spent as much time setting these up with my previous version, which this is just an improved version of this. Less inputs needed, significantly cleaner interface, and all procedurally. So I don't ever have to put anything other. The only work that you have to do with this now is just set your arrays, the settings, and just setting the offset and inverse. Significantly easier than using all that code for each and every single one of these. So I'm gonna go ahead and break these all down into this as well. But yeah, I thought that'd be an interesting showcase to show, and I hope you guys enjoy it.